Welcome to the Mini-Launchers What Place in Europe conference. This is a subject that has been talked about in the space circles in Europe for the last couple of years, in the United States for about the last 5 years, and in China for the last 2 or 3 years. And what it basically says is that the demand of small satellites by governments and commercial enterprises, whether in constellation or in individual form, commercial and institutional and civil, is growing so fast that the existing population of launchers that have been developed mainly by governments over the last 50 years no longer can do the job. So we've seen a couple of new launch vehicles start. They've had their challenges, and there are a whole lot more coming, including multiple launchers in Europe. We have 3 startups who are working on launch technology here this morning. We also have the European and French space agencies, and they are the agencies that are going to decide the role that government plays in the development or the use of these small launchers at a time when Europe's approved family of launchers, the Ariane 5 and future Ariane 6, the mid-sized Vega and future Vega C, are not suffering, let's say, from an excess of demand. So how to integrate a new class of launchers into an existing population that is struggling to make financial ends meet is a real question. And that's why the governments are so important here, because unlike China or the United States, Europe does not have sufficient demand for satellite launches to be able to sustain a population of launch vehicles. Those vehicles have to get commercial or governments outside of Europe into their customer mix, or they're going to face problems. The European Space Agency, since late 2019, at the behest of Germany and the UK and some other governments, has a specified program to assist technically launch startups in several nations. There are 3 in Germany, there's 1 in the UK, there are a couple of in Spain, and there are a couple of more in less developed stages elsewhere in Europe. So it's a populated area right now. We're going to be hearing first from the 3 startups, and I'm going to start with Pangaea Aerospace, which made some news recently with the ever-important announcement about financing. And Andrea, let me start with you, and then we'll run into RFA and ISAR Aerospace. Please.
Okay, so thank you.
First, I guess, who is Pangaea, and then tell us something about what your company does, where it expects to go.
Absolutely. So thank you for the introduction, and thank you everyone for having me here today. So Pangaea Aerospace, it's multicultural space startup based in Barcelona, and
we are get it closer to the face.
And we are developing is better. Okay. We are developing what we believe is the next generation of launcher technology, because as you very well explained, micro launchers are here potentially to stay, but we believe that being competitive in this sector will be key. And actually, in order to do so, we cannot compete with highly capitalized companies, the majority of them in the US, for example. So we've decided to go this path of the building blocks of technology first. And we are developing 2 main technologies in 2 major fields, reusability and high efficiency propulsion. On reusability, of course, we are designing it for reuse from the beginning in order to introduce refurbishment cost at lowest point, of course, in order to have a very low operational cost. And reusability, many people have debated before if it's good or it's not good, but we believe that reusability will give you that extra oomph of competitiveness. Because, of course, you could earn less per launch, but you will be more competitive in the competitive market that we believe is ahead of us. So the first technology is on reusability. We are leading a consortium there with amazing partners in order to introduce a new concept of recovery technology for a booster. So this is one part we really strongly believe in. The second one on the high efficiency propulsion systems. Of course, if you're a rocket company or micro launcher, you need an engine, and the engine, of course, is the most expensive single component out there, and in order to go up or even go down after, you will need it. And we've decided to go to a path into a new type of rocket engine that has been known for Aegis, which is called the Aerospike. It's an engine that could give you up to 15% more efficiency in terms of fuel consumption, and we believe it's yet again putting us ahead into technology because we believe that this new space race for the micro-launcher sector will be about performance and will be about launch cadence, and having a better engine, of course, will be a good asset for us. So we believe that this, with reusability, will permit Europe first to have a better engine or better technology in rocket engine technology. And then, of course, we, we think that starting by that is we can offer it as well. So this aerospike technology has been there for a lot of ages. There are space agencies and research institutions that have been researching on it, but it's now thanks to 3D printing technologies that we can finally get to do it. It was very difficult to cool it down, this type of engine, very difficult to manufacture it with conventional subtractive technologies. And now, thanks to extensive usage of additive manufacturing with innovative copper-based alloys, even with some NASA ones, developed ones that we have access capabilities to do it with GRCOP, for example, it will be possible to manufacture this type of engine and really prove the sector that we can do a very highly performing, reusable micro-launcher in order to be competitive, because we believe that this race is about being competitive, and all this will give you your extra oomph. I want to say as well to finish, to stay tuned, because as you mentioned before, we've just closed a seed financial round, and we are about to test our first engine demonstrator by the end of this year in Lampoldshausen. And of course, if successful, we will scale up that technology, and I'll invite everyone to keep us and to follow us, of course.
Okay, thank you for being less than 5 minutes. So I'll use your remaining minute to ask you
Okay.
a couple of things. First, you raised 3 million euros recently,
Yes.
and you also had some government RT&D financing
Yeah.
that you got as part of a consortium.
Yeah.
So not all that goes to you.
Yes.
So
Correct.
so I'll say that just say you've got 3 plus now in cells, and how far does that take you?
Okay, that take us, of course, to this engine test. So we're going to test not only one but 3. We have 3 test specimens, and of course, when you test any kind of technology, you need spares because things will happen, and this will take us just to pass this test successfully, and then of course we will need to do another Series A round in order to scale up that technology and to think of how to integrate it with our recovery system and reusability system and build the whole launch out of it. But we prefer to be serious on that side, on this, and do not fool us nor the sector. We believe that a lot of people is saying that they will launch in a month almost from now. We prefer to do it steadily, but step by step. First, building the technology that we are creating as assets for our company and the shareholders as well. And then, of course, if the technology is successful, as we believe in, of course, scaling that up.
Okay, and the idea of Pangaea is to start with an Aerospike engine and then develop your own rocket around that, or to partner with somebody else?
It's still unclear,
Still unclear,
to
okay.
be honest. Yeah, yeah. I mean, yeah.
Well,
If we build the technology, for sure, we have already
Okay, and the
some
last one for
interest.
you on reusability. The business model of reusability is an interesting thing to look at.
Absolutely. It's not easy at all.
Right.
It's,
So if you're SpaceX and you want to take people to Mars and then return from Mars, you need reusability.
yeah.
And if you're SpaceX and you can get a bunch of U.S. government contracts, the U.S. government launches more than anybody else, with the possible exception of China. Okay. And if you're SpaceX and you have your own constellation to launch, and it's going to require you launching several hundred satellites a year from now until forever, that gives you, assures you a certain cadence.
Absolutely.
Where reusability seems more easy to integrate. So my question for you is, just give us 60 seconds of what kind of cadence you would need to make reusability from your side worth it.
Okay. So with 4 launches, of reused boosters. Our calculation seems that it's already proving the business model. But yet again, here I want to stress out that reusability is giving competitiveness. Because if you decrease the cost thanks to it, even in Europe, as you have said, there's not enough commercial satellites to be launched. We foresee in the future that that will change, and if you are able to be cheaper because you can reuse it, I mean, you will have there an asset. Yeah.
But a model of 4 launches a year, you think you can make it?
No, 4 launchers to be reused, that be competitive. No.
But what rhythm?
Rhythm, we're talking about, yeah, on a 30.
30 a year.
More or less, ish. That's a rough number.
All right. Let me move over to ESAR Aerospace of Germany. Some of you might have heard a little more about ESAR because they won a competition with the DLR, where 2 other companies will be in for the second round to be decided next year. But Josef, go ahead and tell us about where ESAR is for those who say know almost nothing about you, please.
Sure. So thanks a lot. My name is Josef Fleischmann. I'm Chief Operations Officer and one of the founders of ESAR Aerospace, actually. We started off just as 3 founders, very untypically for the European space industry, directly out of the university, Technical University of Munich, where we built together, not just the 3 founders, but actually also the first 20 employees built together rockets, rocket engines for over 10 years. And out of this environment, we founded the company 3 years ago in 2018. It was a classical startup story, but from the beginning we were very successful in convincing both private investors as well as customers. So the background for us is why we made this company. We wanted to really make a commercially viable product. ESAR Aerospace is therefore very oriented towards the market, and proven is that by large contracts that we already got from ventures like Airbus, but also other startup companies. Constellations is, I think, a topic, mega constellations that we will speak later about, where you can really put small micro launchers to a very good use. When we look at today's market, we have Ariane, we have Vega, we have in the US the really large launchers. But we noticed in the market there is a little change. We now have super small satellites, we have constellation of small satellites, and this is where the ESA Aerospace launcher is geared towards, and this is where the business is going to be in the future. And as I said, together with our good team, we had a very similar seed round 2.5, 3 years ago. We went then, as Pangaea Aerospace, we went then into a larger investment round in 2019, and since end of 2020, we are basically financed through to first launch with a total sum of money available of 100 million euros, roughly. Yes, with that kind of money, the technology we develop is very classical, but geared towards high reliability, low build cost, and very much towards the market. And we're very happy to see that. We won, as you said before, the DLR micro launcher competition. And we think that is due to our high orientation towards customers, actually. Where we already started investing super early into how to look at how can we integrate satellites properly, how can we serve a customer from the first moment to the last moment. And then what is another big step for us is we want to develop a manufacturing capability that is not known so far in the space industry, by really producing rocket engines in a much larger quantity, like we see in the US from SpaceX. Really almost have, in the best case, a series production, and we have been on that now since over a year. We have optimized production actually also available in our manufacturing hall. down in Munich. And yes, from there on, we look into right now building our first launch pads, and then going for first launch as quickly as possible. So that's, long story short, ESA Aerospace.
Okay, and I believe, correct me if I'm wrong, that you just had another funding round a couple weeks ago, did you?
We cannot comment on that one right now.
Okay, that was a non-commentable 57 million euro round led by, I can't remember which venture capital company in Germany, I believe. But that takes you to a level that is certainly comfortable for you to get all the way through your first couple of launches. Is that fair?
What we can say, I think, is, as I said before, we are financed through first launch, definitely. What also is important for us is ESA Aerospace. We can place it now as a neutral, and that's what it meant for, as a neutral and independent launch solution out of Europe. And what I think is really important, and that's why we're also here today, is we need to be able to compete with US and China. And I think from that perspective, ESA Aerospace, with the technology and the customer base and also the financing, is extremely well set up to be that part of the European space industry that can really take on that competition that we see in the US, extremely well financed, extremely technologically credible, and in China, newly emerging.
Okay, and then just very quickly, we heard from Pangaea on the choice of reusability from an engine maker point of view. You're building an entire rocket, and up to now, this is expendable hardware, right? It's not reusable?
It is meant to be reusable in the future, but right now I can confirm that ESA Aerospace is a company that completely focuses on its micro-launcher product, and we have to demonstrate that we are capable of building it, that we're capable of launching it, and from that moment on, we take next steps.
Okay. And your business model tells you that you can reach cash flow break-even at what rhythm of launches on an annual basis?
It doesn't require that much, so but I cannot say the exact number, but it's not super high. It's in the order of magnitude of 10.
So between 100 and 0?
Yes,
no, but around
yes.
Single digits. Then you think high single digit numbers a year.
It's so our launch is designed to be extremely competitive. That's why we don't need to have super large numbers to launch. We also think that ramping up is not so realistic to launches like of 50 or 100 per year. When we look at other launches in the world, you look at SpaceX. They have a really high cadence, but it also took them quite a while to get there.
Yes, it did.
And that's a path that we can imagine to go down as well.
Fair enough. All right, we'll come back to a couple of these things. Let me move on to Rocket Factory Augsburg, aka RFA1. Should we talk? You refer to you now as RFA1 or Rocket Factory Augsburg?
Rocket Factory is
Rocket Factory. I like Rocket Factory. Anyway, so Stefan Brieschenk is CEO of Rocket Factory Augsburg, which has the great good fortune to be supported by OHB SE, one of the 3 space system primes in Europe. Stefan, please tell us about RFA.
Yeah, thanks for inviting us for this panel talk this morning. Rocket Factory was founded in 2018 with a mission to provide low-cost access to space, and we were really born out of a study from the European Space Agency. This ESA study really honed in on 3 really fundamental questions. The first one is, what technologies really make a difference? If you want to offer low-cost launch, what tech really makes a difference and what doesn't? The second item was, how do launch vehicles actually scale? If you take a Falcon 9 and you just make it smaller, you are not at the optimal solution. And the third question was, what architecture can really compete internationally, not just in the European framework, but internationally with all the 100 players out there. And the outcome of this study really laid the foundation of Rocket Factory. And the architecture we're working against is a launch vehicle that puts 1.3 ton of payload into space, into a 700-kilometer polar orbit, and it's based on 3 disruptive or key technical aspects. The first one is we make use of staged combustion propulsion systems. That's the biggest element technically. The second is that the launch vehicle is made at ultra low cost from stainless steel. The study that we did with ESA has resolved this just a few months before SpaceX announced that Starship is indeed switching from composite to stainless. And last but not least, we see that the biggest advantage for our customers is an orbital stage. We have a 3-stage launcher, but the last stage is a hybrid. It provides some DV towards orbital injection, and then it can serve as an orbital stage. On the company, we're 80 people to date. We have only spent 15 million euros. This for us is very important because we want to be the company that completes the development program with less money compared to all the 100 programs that are out there. And this brings me to the next point. We have investors that bring more than just funding to the table. We have investors that bring technology, that bring a industrialization, manpower, and basically allow us to get back to experience of 3,000 people whenever we need to. So we really have the best of both worlds. We are a startup. All of our people have shares in the company, but we are backed up by some really experienced industry. And the last point I wanted to make in this introduction is that last week we completed our biggest milestone, and that was the qualification test of our staged combustion engine, which we test in Kiruna, and we have a quick 40-second video to show you the results. Yeah, basically, that's it from my end.
Give us a resume of what we just saw.
What we just saw was basically a full-scale, completely integrated test of our staged combustion motor. It includes all elements of the flight engine. And what you see there was the 8-second power pack run and the 2-second hot fire. So we're super proud of this because at the end of the day, what matters is what is your technical achievement, mostly propulsion. Rockets are all propulsion, and how much money have you spent? And this is the most important gradient for us.
Okay, and on the financing, you said you've spent up to now 15 million euros. And where are you? When do you need to go out to get supplemental financing?
So we think that in the worst case, we will need up to 100 million euros to complete the development. But in the best case, we need less. We're looking for financial partners who want to participate, but we want to mention we have very strong backup in investors already.
Fair enough. Okay. We might come back to some of this, but I see they've already nipped some of our time that I thought was remaining, but we'll negotiate that at the end. So let me move to the two agencies now, starting with the French space agency, Quelle, and Jean-Marc Astorg, who has a long experience with launchers. Jean-Marc, what does Quelle think about mini launchers in a European context?
Good morning, everybody. Thank you, Peter. Yes, micro launchers are important for CNES, and I have to say that we spent some time recently to define our position, our strategy with regard to micro launchers, even if our top priority for launchers is Ariane 6. We are at the end of development of Ariane 6 with a first launch next year, so we are also working a lot on Ariane 6. So for micro launchers, we address the issue from different perspectives. The market one, the technology, which technology is it of interest for bigger launchers? The funding, how can it be funded? Is it a purely private funding, or is there a room for public funding? And the European cooperation, because as you said, first these micro launchers will have to fit in the European launcher family, and of course, since we are promoting European cooperations like ESA in the field of launchers, we are also concerned about how it fits. So concerning the market, we have to, I think, distinguish between two classes of market for micro launchers. The micro launchers with a capacity of less than 300 kilograms, and the mini launchers with 1 ton of performance. And we believe there are two different classes of vehicles with different markets. So to make a long story short, for micro launchers, we believe the market is quite limited, with a maximum of 10 launches per year. For mini launchers, it's quite bigger. We believe there is a room for 10 to 20 launches per year, which is quite a lot, because there are a lot of satellites which are now of reduced size, which can be launched on these mini launchers. You know, there is a boom of small satellite projects, but also we have to keep in mind that most of these satellites are belonging to constellations. And if you take, for instance, the number of small satellites launched in 2020, 87 were part of constellations and have been launched on big launchers. So we believe that at the end, the market for micro and mini launchers will be certainly limited to very specific applications, like military applications, when you want to launch quickly or with a very confidential basis. You don't want to share your launch with other customers. But still, there is a market, even if at the end there will not be 10 micro launchers operational in Europe, but I think everybody knows that. Now, the technological aspect. We look at that because we think that there can be very interesting technologies developed by these guys, applicable to big launchers. For instance, reusability. You know that in CNES we believe that the future of launchers will be based on reusability. So what can be done on micro launchers could be applied to bigger ones. The propulsion systems, methane, we believe we are going to use methane for the future. So there are a few projects using methane. It can be useful for us too. Also, what can be said is that we believe that the barrier today to develop a micro launcher is much lower than 10 years ago. For instance, 10 years ago, to buy on the market an inertial system, an accurate one to make your control of the vehicle was very difficult. Now you have one in your handy, so it's quite easier today to develop a launcher. So maybe, Peter, you could develop a micro launcher in your garage if you want, not less. But you still need a lot of money. The order of magnitude of the development cost of a micro launcher, it has been said before, is between 100 and 150 million euro, which is still quite a lot of money. And that will not be paid by public funding because it's based on private industry. So the return on investment is obviously an issue, and we have to know that. Now, if you look to the different actors, there are about, let's say, 10 to 15 startups in Europe developing micro launchers, not only in Germany or in Spain, but there are a few in France too. So at the end, probably one or two will succeed, the best one, we think. So what we are doing in CNES at the end for the micro launcher class, let's say less than 300 kilograms of performance, of course, we foster these private initiatives. We are there to encourage them, to help them, maybe to fund some technological activities which are related to what we are doing for bigger launchers. We are also acting from the customer side. For instance, we are currently developing an autonomous safety system for Ariane 6 and Vega C. A system which is able to stop the launcher flight if there is a problem. Certainly, we could test that system on small launchers. It will cost us much less than a bigger one. We need about 10 launches to test it. So micro launchers will be a perfect opportunity to test that for low cost, and we could be able to fund 10 launches from Kourou. So it can be very interesting for these micro launchers. Just an example. For the mini launcher market, it's quite different because we believe we can use that class as a pathfinder for bigger launchers. So, for instance, we could think of a mini launcher, two-stage, using LOX methane propulsion, reusability, which could be developed in an European scheme with ESA, in the frame of ESA, but with a different, certainly, governance. And that could be together some kind of mini launcher and a way to prepare Ariane 7 or Ariane Next or the future family of European launchers. And finally, I'd like to say that all these startups or launchers are welcome in Kourou. We are currently revamping the old Diamant launch pad. We are working on that. We are funding that with CNES money. So all are welcome in Kourou, and we are discussing with many of them to launch this very interesting project in Kourou.
Okay, just a quick one for you. So when you're talking about the mini launchers, because I think that's what we're mainly talking about here. So that's up to a ton in a LEO orbit, and that's 700 kilometer, all right. And you said that there's enough market in Europe for 10 to 20 launches per year of that kind of launcher?
Yeah, this is an Arianespace estimation, by the way.
So that's 10 or 20 launches that didn't want to go to Vega on a ride share and didn't want to go to Ariane 6 on a ride share for whatever reason, correct?
So it's a matter of launch price as well. No? Of course, it has to be attractive with regard to other possibilities.
Okay, all right. We'll come back to some of that because I think the CNES position on these mini launchers has shifted over the last couple of years. But let me go to the European Space Agency and the director of their space transport division, Daniel Neuenschwander. Daniel, how does ESA look at this issue?
First of all, I think it's great. It's great to be in a panel less than 2 years after Sevilla, the last ministerial council we had, to be in a panelist with three young companies, and I will come back to it why. Because it's clear that for ESA, we are developing right now Ariane 6 and Vega C, which should be available next year, 22. We guarantee through ESA-developed launchers the European access for the full spectrum of customers. And that's one family which is guaranteed from Vega C up to the Ariane 64 for tomorrow onwards. But we thought at ESA that we have to go one step further, and this is why we have launched the program BOOST, or better known under Commercial Space Transportation Services, at the last Ministerial Council in Seville. And I think it really helps to give framework conditions to favor actors like we have today on this panel. And I will give you some elements due to that, because we are convinced that we need innovation. And diversity leads to innovation. So I think it's a real opportunity. But we have also to be clear about the framework. And we created this program BOOST under the leadership, or let's say the most important countries in terms of funding were Germany and the UK in Sevilla, but others were following. And I think it was really a new starting point. And what have we done? Because it's important to recall the conditions, the boundary conditions. First of all, we act as a partner as ESA. We don't act as a customer. This may change for future programs, but let's not change the rules in the middle of the game. So within BOOST today, these are the boundary conditions. Second, we leave the full project and full responsibility to the service providers. I think it's also a different way of proceeding from the ESA side. We are very rapid in contracting with regard to other programs. We are light, but we also give the responsibility to industry. And we provide, on the other side, know-how and expertise where the company needs it most. And we have currently 5 small companies who deploy new commercial launch services, or with the aim. And the type of support is fundamentally different from one company to the other. And I think that's also important to keep in mind. We give them access to test facilities, and this is also, let's say the larger scale public facilities, which is, in our view, a key enabler also for young companies to really get in this market, because it's not easy, of course. And last but not least, and I think that's fundamental, we facilitate them to get private funding, because we saw that some companies, after having had a ESA stamp or already being in contact with ESA, could raise public funding in a different way. So that's a bit the framework. And then about the future, I have to say I'm quite open. Well, I'm really open. I'm looking forward to that. What is clear, that if you would go in a direction where European customer or ESA missions, I can speak about ESA, but if we speak about ESA missions, which should be launched by other launchers than Ariane and from the Ariane and Vega family, then let's keep in mind that we would also need a kind of certification process.
Okay. Which are the 5 companies that are now associated with Boost?
So some are sitting here. We have on the German side, we have ESA, RFA, and High Impulse, who are under contract through Boost. And on the UK side, we have Orbex and Skyrora.
Okay. But that's not, you didn't set a limit at 5 and then it closes the door.
No, not at all. And I would like to underline, Boost is not limited to micro launchers. Boost, it's really to commercially led space transportation services. And I'm looking forward to develop this program as the next Ministerial Council much beyond. We want to go to transport in space. We want to go to return from space also in this type of logic. And let me jump on what Jean-Marc just said. He spoke about, let's say, a kind of program where we could have a rapid qualification. I think that's quite crucial for all the actors here in Europe, established or new actors, to have rapid qualification and to make it that you can really refly it on a regular basis. We could develop such a logic in an enhanced boost context, but that's up to the participating states to define the rules of the game at CM22.
Okay. Obviously, what all these startups want, and the ones that aren't here, they want contracts from ESA, even more maybe than they want development funding. So what is the process of certification that you'll go through to get these companies in the list of launchers that can compete for ESA business?
Today, we don't have set it up, because let's be clear, today we have the Ariane and Vega family, but I just give you a point in ahead that we have to work this out. Because if you really want for ESA mesh, before you are really having regular and recurrent flights, I mean, it must be clear that you, with this launch service you provide to an institution like ESA, you have to demonstrate your capacities. And I'm just saying this as, take it as a challenge. Huh? I see it as a great opportunity. It will also change the role we as space agencies, I also speak for other ones, are interacting with these type of factors, and that's the next step to go.
So for a launcher to be eligible for future ESA contracts, that launcher would have to have launched already?
It's up to the participating states to define the rules of the game, as you know.
So this is something...
But we will propose a scheme.
You will propose in late 2022 to your governments, correct? Is that right?
If this is confirmed as a need, I give you my view. If this is confirmed as a need from the states, we'll work it out. Yes.
All right. Okay, let me ask the three of you guys in the same order we went for. First of Pangaea, what could you use most from ESA right now? Don't say cash, because you're not going to get that. So aside from cash.
I mean, as Daniel said, know-how, technical know-how. I mean, for us at least, ESA has been doing this for much more longer than we have. So I would say know-how. I mean, technical expertise and helping us out building the technology we want to develop. Yes.
And how are you going to get that?
I mean, we'll speak it out. I mean, I'm trying to contact them and yeah, prove first that the technology that we're developing, we are doing it in a, yet again, serious way with them taking the most margin we can and then with their help, making it possible.
Okay, so in Europe, what you normally do is you go through an individual government that's a member of ESA and get that government to go to Paris and lobby on your behalf. So who's your home government?
I mean, Spain, of course. First, we talk in this case with CETI, which is a representative in Spain, and try to convince them that the technology we're developing is good and will be even better, and then moving on to the ESA side, of course.
Okay, I have similar questions for ESA and for RFA. Both of you, by the way, have struck deals with the Pangaea Space Center in Norway, which has been launching suborbital sounding rockets for several decades, and so knows something about that. They don't have a lot of islands and oil tankers outside off their coast, so they have a nice trajectory you can use, and they want to start operating orbital launches as well. And you two, both your companies have signed deals with them. So let me start with ESA. Joseph, what do you've got your DLR ticket, which came with 11 million euros. And with that ticket, you're supposed to be able to go to ESA and say, I've got my DLR ticket, so I should be able to get something from you now. Is that right?
In essence, it's the right direction, yes. So the Boost initiative was mentioned, and the way that Germany set it up, we really liked it, because it was set up in the way of a competition, really. So it's how the US does. They basically don't finance developments.
Right.
Instead, they give contracts and let private investors finance the development. And that's exactly how we like it. We could win this DLR contract, which is actually launching satellites. And then for us, the private investors will do the development. So that's I hope that answers that part of your question.
Maybe, but have you gone to ESA since you won the competition in May and said, we should now look differently to you at ESA than we did before?
Well, we are in contact talks with ESA,
okay.
But as you said it, what is interesting for us from the ESA side is basically, yes, these types of competitions, contracts, but also what is interesting for us is a framework that ESA can provide, and as said before, infrastructure. Which a startup has to build up first, but ESA has decades of experience in.
Yeah, then now you want, before I
Let me just compliment about how it goes, because what Germany did, they have installed a kind of national pre-process of selection.
Yeah.
This is what he was referring to. Then what is very clear, that the winner has to come to ESA with a full proposal. Mm-hmm. And there he has, of course, to go through the hurdle according to the rules of this program, meaning that there is not only the technical feasibility demonstration in the Boost program, you have also to demonstrate that you can reasonably sustain your business. And this will then, and once you have gone through this, you will get the full support from ESA.
Right, that's
a compliment.
It's a tough hurdle to demonstrate you can reasonably sustain your business. NASA doesn't ask that. They ask you to perform a service with the launch, and you perform the launch. They don't ask for a guarantee that you're in business for 10 years. But Stefan, let me ask you the same question. You're now in the second round of the DLR competition that's supposed to end up with another 11 million euros in about 11 months or so, under the same conditions as the first. That would be in mid-2022, before the next ESA ministerial meeting. These things get complicated, but Europe is complicated, right? So what do you expect to get from ESA between now and then? And let's just assume for the second you're going to win that round next year. What would that do for you?
So to put it in a nutshell, look, we are looking for more payloads to get into space. Let's be very honest, I want to play the devil's advocate here. The US went to space 40 times last year. Europe went into space 4 times. Funding in the US per person for space activities is 5 times higher than it is in Europe. There's a technological race happening between China and the US. And I'm talking not just for Rocket Factory now, I'm talking for an entire generation of European engineers, we don't want to left behind. We don't want to be left behind. We expect Europe to come up with large infrastructure that is put into space and payloads.
Okay, but unless you're going to import the US Air Force into Europe to provide all that demand, you have a problem that's not going to go away. Europe will never, at least in our lifetimes, I'll predict out more than 10 years, Europe will never have as many launches required as the US government does. That's just, or the Chinese government. So how do you square that circle?
So the squaring of that circle happens with being able to develop a product that is internationally competitive. You mentioned it in the very beginning. We can't survive with just the European payloads, and that's why we need to develop a product that's so competitive that it's compelling for customers outside of Europe. And we're on a fantastic path towards that result. I've mentioned before, we've spent 15 million euros. At this point, we have a properly functioning engine. We're on that path, and it's looking good.
Where your engine comes from Ukraine?
We partner with a company that also develops and builds the upper stage of the Vega rocket, and we have completely developed the engine at Rocket Factory in Augsburg, but we use engineering services from a large network of known players, very strong players, and one of them is Yuzhno in the Ukraine, correct?
Are there any supply chain issues that DLR is asking you about and ESA will ask you about?
I have to say a huge thank you to DLR and ESA because we have basically discussed this very early and we've made sure that we set everything up that there are no such issues in the future.
Jean-Marc, so now that we're in the cheese course, because they only have 8 minutes left, we can go to some of the questions that I've been waiting to ask you. First is, why would CNES want to support small launchers in Europe? All it will do is divert funds from the current family of launchers that can launch what governments want and what some of the private sector wants. Why divert effort and energy and capital into a new launch service that probably isn't going to make it anyway? That's the argument. That's the devil's advocate.
No,
how do you answer?
I think I tried to explain to you why when I first spoke. First, because it is complementary to what Ariane 6 and Vega C will do. So we see it as a complementary launcher services, which will be useful for certain applications, first. Secondly, because the technology could be very useful for bigger launchers, reusability, LOX metan propulsion, specific equipments, tanks. For instance, Rocket Factory has developed a very interesting stainless steel tank production method. So we can use that for bigger launchers. And also, as I said, they are all welcome in Kourou. And that complements the activities on the launch base. You know that Kourou is the ideal launch base for every launchers, big, medium, and small, because it can launch to every orbit, which is not the case for other spaceports.
And there's more sun than in Norway. So, no, but
you said that.
I did. In late 2019, when ESA produced this program, Commercial Space Transportation Services, otherwise known as BOOST, right? It was mainly Germany paid for half of it, UK paid for about a quarter of it, and 4 or 5 other governments, I can't remember them now, paid for the rest. France was not among them.
Yes, and there is a good reason for that. Daniel said that this program is made to provide a technical support to these new companies. In CNES, we have another way to do that. We have the Connect by CNES program, which is exactly intended to help a new space startup, not only launchers, but applications and so on. So we do it from a different way, but the objective is the same as ESA.
Is Connect by CNES, and I know that program, I'm used to it mainly on telecom payloads. Are there launcher startups in that program?
Yes, there are startups, and also I'd like to mention that we organize very regularly in CNES pitch days or challenge days to award contracts for startups, especially in launchers, on a regular basis with a quick access to CNES contracts. We did one 1 year ago, and some French startup for micro launchers won the contract. We have done one last month, and we do one again in October. So it's another way for contractors to get very quickly a CNES contract to help to develop technologies, services, and so on. So it's complementary to what ESA is doing.
Right, but the main part of the financing is to come from the private sector, not from government programs.
Yes, it's
Correct.
Complementary to the private main funding of these projects. Yes.
Okay, all right. Danielle, just a quick one here. Of the 5 companies that Boost is now dealing with, 2 of them are in the UK. One has made specific advances on a Scottish launch site, as you know. and has raised a certain amount of money. But the other one has the merit of existing as well, and I think also has some Ukrainian heritage. When you're looking at these companies, unlike companies from Germany or Spain or Italy, you have to think it's all very nice, but even if we give them some contracts at ESA, they cannot get contracts from the European Commission because they're not European, right?
Well, first of all, the UK is part of the European continent, and it's a member state of ESA. So it is clear that all our programs, we do them for all our member states. Then it has been mentioned before. I mean, the real competition for space in Europe is on the other side of the Atlantic, and of course in China. So frankly speaking, I do not really catch this debate, because can we afford within Europe to have such discussions? I think we should pool all our resources and think as a continent of Europe in this context.
Why?
I was just saying that considering where the competition is coming from in Europe, we should pool all our resources and make sure that as a European continent, we make sure that we have the best solutions. Because as it has been said, the competitive aspect is, of course, taking place more and more also within Europe. And I think that's healthy. But if it's a question of surviving or not, is also driven from what happens outside Europe.
Certainly true. And all I can say is that you have some persuading to do in Brussels to make that happen, because right now their policy is not in that direction. Well, we've only got a couple of minutes left. Pangaea, tell us specifically the next 12 months for you. No further than that. A couple of milestones that we should look forward in your development. You've got the development of your motor in the third quarter, I think.
Indeed, in the next year, we're gonna first test our engine demonstrator, which is a Methalox Aerospike, dually regeneratively cooled with both propellants, fully 3D printed in 2 different copper alloys in Lamposhausen and DLR. And then we're gonna do a drop test of our recovered technology as well, of our little prototype, not even 2 meters long, potentially in Kiruna. It's not set on stone yet. So we have 2 main technological milestones ahead of us in the next 12 months, for sure.
You're doing this on a commercial basis with DLR Lamposhausen, or?
Yes, correct.
Okay. Doesn't Spain have a place that you could test fire?
Not yet, at least. We are working, of course, on having our own tests.
Okay,
sites
next
there.
12 months. A couple of milestones for you guys.
Yes, for us is of course important in the next 12 months. A lot of infrastructure building, launchpad. That is what the construction will start soon on. Then we have qualification campaigns for engines. We have campaigns then, of course, for stage testing. We have, of course, more work to do towards customers as well. So that's as a total our goal in the next 12 months. Also growing our team further. It's almost completed now, but we're gonna go through the 200 employees barrier quite soon. So that's in a nutshell.
Okay.
Our next 12 months.
Okay.
But most important, of course, launchpad building, because that will take.
In Norway.
That's the first one confirmed, an exclusive first launchpad on Andoya.
Okay. Stefan, next 12 months.
A competitive launch vehicle is all propulsion, so we focus on propulsion almost exclusively. The propulsion system we have right now has a C-star performance of 94%, and we want to raise that by 2 percentage points, and we want to basically integrate the engine into a stage and demonstrate a complete stage burn within these next 12 months.
Okay. And presumably win the second round of the DLR competition.
That's one of our objectives, but
how important is that? Is that important for you or not? Or is that
it is important, but more important is to get the propulsion system to a state where it can compete in efficiency with all these 100 startups.
Okay. Jean-Marc, is it safe to say that France is likely, no commitments, likely to join the second generation boost that ESA will probably propose to its ministers, including the French government, in late 2022?
I would say yes. We are discussing with ESA, and As I said, what is interesting for us is to see how that activity could help to prepare future launchers, future bigger launchers, especially from the technology point of view. So if we can mix this new approach, the dynamic attitude of these colleagues with the preparation of future launcher in an ESA context, that will be wonderful.
Very good. All right, Jean-Marc, that's the last word. They're giving us the hook. We've got to say goodbye. Thank you in the audience for listening, and until next time.
Je suis fière de vous annoncer l'ouverture de nouvelles cloud régions. Avec près de 30 régions dans le monde, c'est maintenant le tour de la France. L'objectif pour nous est de renforcer la proximité avec nos clients, de répondre à leurs besoins de souveraineté, de protection des données, avec une infrastructure encore plus performante et plus compétitive. Ce n'est pas seulement l'ouverture d'un data center, mais d'une région. Une région est une unité qui peut comprendre plusieurs data centers qui peuvent être agrandis, étendus en toute transparence pour nos clients. La France Cloud Région sera connectée à l'ensemble des autres cloud régions dans le monde grâce à un réseau fédérateur. Cette connexion sera en permanence active, sécurisée et dédiée. Cette nouvelle architecture, Security by Design, a été conçue pour apporter plus de flexibilité, plus de fiabilité dans une approche multi-cloud. Elle va pouvoir héberger les workloads les plus critiques et exigeants de nos clients et répondre à leurs enjeux environnementaux. En effet, tous nos data centers en Europe utilisent d'ores et déjà 100% d'énergie renouvelable. Vous en apprendrez plus dans les prochains épisodes. Restez connectés.